大家好，我叫 Chavis. Hello everyone, I am Chavis von Bradford. How many universes could exist in the multiverse, which is a vast hypothetical collection of various universes? Russian scientists Andrei Linde and Vitaly Vanchurin explored this by estimating the number of locally Friedman universes, which are regions that look like our own universe on a large scale, and how these regions were generated by eternal inflation, which is a process where space expands forever in some areas while stopping in others to form individual universes. The researchers found that this count depends on the exponential, a mathematical way of showing extremely rapid growth of the entropy of inflationary perturbations, which describes the amount of disorder or complexity in the early fluctuations of space. This is limited by a value related to slow roll e-folds, which is the specific stages of time during which the universe expanded steadily and gradually. In simple chaotic inflation models, where the universe is thought to have started in a very disordered state, this number can be as massive as the de Sitter entropy, which is a measure of the maximum information space can hold. Within the string theory landscape, the massive map of all possible ways a universe can be structured, the total number of universes is even larger than the total number of vacua, or the different possible stable states for those universes. Ultimately, the true limit of what we can count might not be the multiverse itself, but rather how much information a human observer can actually possess. The main equation is script n scales as to e to the 3n sub top, which quantifies the number of distinct locally Friedman universes produced after the full slow roll phase, with n sub top quantifying the total e-folds since eternal inflation ended. For chaotic inflation with potential, V equals 1/2 m squared phi squared, which is the simplest chaotic inflation potential where the inflation mass m determines the amplitude of perturbations and the number of e-folds. And m is approximately 3 times 10 to the minus 6, which is the inflation mass in Planck units required to match the observed amplitude of the cosmic microwave background fluctuations. The yielded result is n sub top scales as 10 to the 7, which represents a time after eternal inflation ceases in a given region. The universe still undergoes roughly 10 million e-foldings of ordinary slow roll inflation. This enormous expansion stretches quantum fluctuations to macroscopic scales and imprints a correspondingly huge number of independent classical configurations, forming the basis for the double exponential count of distinguishable universes. All of this mathematics yields a final result of script n scales as 10 to the 10 to the 10 to the 7. So according to the mathematics of this specific model I just stated, there are 10 to the 10 to the 10 to the 7 distinguishable universes in the multiverse. However, the Bekenstein bound limits a human brain's practical information processing capacity over a lifetime to about 10 to the 16 bits. As a result, the human brain can only comprehend 10 to the 10 to the 16 of these universes. One significant challenge to this theory is the swampland conjecture, which refers to a set of criteria in string theory that distinguishes valid physical models from those that appear consistent but cannot actually exist. This threatens the validity of the landscape, the vast collection of possible vacuum states in string theory, and eternal inflation could make this null and void. Critics also argue that the massive numbers calculated are simply artifacts of coarse graining, a method in physics where detailed information is averaged out to simplify a system rather than representing actual physical universes. Furthermore, the counting process is criticized for not being gauge invariant, meaning the results can change depending on the mathematical coordinate system or the gauge used by the observer. This suggests that the distinction between pocket universes may be coordinate dependent rather than a fundamental physical reality. Another technical concern involves holographic entropy bounds, a principle stating that the total information within a region of space is limited by its surface area. Some infer these bounds are violated by the sheer volume of the universes that are proposed. Finally, many scientists point out that the entire research program is empirically sterile, as it lacks a way to be verified or falsified through observation or measurement. Since these other universes are beyond our cosmic horizon or the particle horizon, the boundary of the observable universe in which we can see, it is very challenging to prove their existence. However, there may be things in the future based off of primordial gravitational waves, pulsar timing arrays, higher resolution of the cosmic microwave background and the cosmic neutrino background that could help us falsify this hypothesis, model, and theory.